Okay, so chapter 7 is geometry, okay? You're in luck because I've taught geometry longer than I've taught algebra. So that means I'm really good at it, right? Just like you're going to be. So 7-1 is classifying angles, and 7-2 is just complementary, supplementary angles. Since 7-2 is really, really short, I just combined it with 7-1, okay? But the first definition we have is vertex, a vertex. Some of you have heard this word. This is the point where two lines meet, forming an angle. It's a point, okay? You can have a vertex in a triangle. You can have a vertex in a square, a rectangle, any polygon that's closed, you can have a vertex. You can also just have vertex in regular angles, like on the pretest and on in the book when you guys measured the angles, you had vertexes, okay? So there's a picture of one, and then next to it, I put the, just a quick review, complementary and supplementary, what they mean, okay? And then here's your angle types. I'll let you guys get all this written down, and then we'll talk about them. I think most of you guys know these angle types, hopefully from elementary school. But just in case you don't, there they are again. Okay, so what we have, guys, is we have our picture of our vertex, little review, complementary, supplementary, and then we have our four angles. We have a right angle, this little box right here. Whenever you see that, it always is going to mean 90 degrees, okay? So whenever you see that, they're not going to write 90 degrees, they're just going to put the little box. Have you guys seen that before? Yeah, some of you? Okay, acute is less than 90 degrees. And it sounds cute, doesn't it? Like a cute little angle? No. No? But obtuse sounds kind of like an ugly, big angle, huh? No. No? Okay. Well, obtuse is greater than 90. That's how I remember. Obtuse is greater than 90 degrees, and then straight angles are just flat lines. So they can go up and down vertically, or they can go horizontal, or they could just go like straight diagonally, okay? But there's no extra angle in there, it's just straight. Okay? Do you guys know, this is like a bonus question, I'm going to give you a candy if you get it right. Okay? So raise your hand if you know what this, like just this line might be called in geometry. Just one of these lines, what they're called. And here's a hint, they're not called lines. One of these lines with the arrow at the end. Does anyone know? Zach, you know what they're called?
A line segment?
No, line segment wouldn't have an arrow. Anyone know what a line with an arrow at the end is called in geometry? It starts with an R. You know, Jimmy? Array. Good. You want a candy? All right. So it's called a ray. So a line segment will have a start and an end. And sometimes they put a little dot at the ends. But a ray has an arrow at the end. Yeah, good job, Jimmy. Okay? So those are the angle types. Now we also have the special angles called vertical angles. You're going to use these a lot in 8th grade too. They're opposite angles and they look like that. Okay? So it's just like an X marks the spot, right? Like a treasure map. And they are the angles opposite each other. Okay? They're always congruent. This little symbol means congruent, so you can use that. You don't have to write the word congruent anymore. It's an equal sign with a little squiggly line. If you speak Spanish, it's an ñ. You guys know ñ? Okay.
Well, I'm surprised.
So these little symbols mean congruent. So in here you would say angle 1 is congruent to 3, angle 2 is congruent to 4. They're called vertical angles. And we use them to prove things all the time. There's a bunch of geometric proofs, okay? That's where they start. Any questions so far? Raise your hand if this is like review for you. You've done a lot of this. Good. Good. Everyone's going to get an A+ on the first quiz. Or first quiz is a lot like this, so, you know. Okay? And then we also have adjacent angles. Okay? So within that same picture, we have adjacent angles. Adjacent means next to, right? So 1 and 2 are next to each other. 1 and 4 are next to each other. 2 and 3, and 3 and 4. So vertical angles, adjacent angles. And the reason you need to know the difference is on the test or the quiz, it'll say list 2 vertical angles, or it'll say list a pair of adjacent angles, something like that. So you need to know what they're asking you to do. Have you guys heard this term too, adjacent angles? Yeah? Okay. So far we've done like no algebra, right? There's no solving for anything. Do you see any solving for anything there?
No.
Do you think that we will have to solve for something?
Yeah.
Yes. Yes. So you're going to take your knowledge of algebra and apply it in geometry. The only big difference is it's visual. So for people who are like, I can't figure out this algebra stuff, like I don't really care what x equals, right? Admit it. Who's like that? I don't really care what x equals, right? So in geometry, x will equal some sort of value that can be applied to an angle. So now it's visual. You're like, oh, x is 80 degrees of that angle. That angle is 80 degrees. So it starts to make a little bit more sense in geometry. It's a little more like practical or applicable, right? Real world stuff. You guys almost got this? Now, if you write these out of order, like say you put 2 and 1 on adjacent, it's okay. They can be out of order. There's no particular order. So don't worry about that. Same with vertical, like if you wrote 3 was congruent to 1 or 4 was congruent to 2, it's the same thing, right? Because they're congruent. Yeah?
Are you going to show us more adjacent angles?
Well, when we solve for complementary and supplementary, you'll see what I mean. Okay? But for that particular picture, there's those 4, right? That's it for that one. Okay, the next page. So this is what I mean when we're talking algebra. It'll say find a missing measure.
Is this 7-2 now?
This is all together in one.
Oh.
Okay? 7-2 is really only the complementary supplementary stuff. So I just kind of put them together. So when you find a missing measure, like this one here, this is where you're going to use your algebra knowledge. These are 2-step equations. Let me zoom it in just a little bit for you guys. Is that better?
Yep.
Okay. So we have this shape here with these vertical angles, right? And adjacent angles. And we need to solve for x, and then we need to solve for y. So how do you guys think that you would go about, let's just say, solving for x? Any ideas here? There's 2 ways. So, Sarah, you're thinking?
Yeah.
What do you think?
Distribute.
Distribute? No, that sounds too hard. Let's do something easier. Josh? Add what?
Add x plus 2 and subtract 2 minus 2.
Not quite. Any other ideas? McKenna?
Add the two things differences and add the two.
Can you add x and y together though? No. So let's just ignore that one, okay? Don't think about that one. How would we solve, Nick?
Which one are we talking about? Y or
X. I want to try to solve x.
Okay, so because of the two angles, 130 and
The vertical angles?
they're gonna be the same.
Yeah.
So you want to subtract 2. which
Okay,
is
so he
opposite
said these two are the same, right? So if they're the same, I can set them equal to each other, right? Like that? Is that what you said? 2x plus 2 equals 130? Because they're vertical? Does everyone see that?
Yep.
Yeah.
And then he said you subtract 2 and then you divide by 2. I heard you saying that. Good job. So subtract 2, right?
Why do you do that?
So we can solve for x. Just like a regular two-step equation that we've been doing. Yeah. So we subtract 2, we get 2x equals 128. Divide by 2, and you should get x equals 64.
Oh, this is easy.
Yeah, 64. And then you know what? You could even plug it back in and make sure, right? Because you know it has to equal 130. So if you plug 64 in there, it should equal 130. What about, like, is there one other way that you could solve for it other than vertical? Yeah?
Horizontal.
No? Like, but what? I think I know what you mean, like sideways, like this? So, but how would you do that then? Like, so you're saying that and that one, right? So how would you set that up? Not sure? What do the two angles on a flat line have to add up to?
180.
180. So if you did 2x plus 2 plus 50 equals 180, you could also solve it. To me, vertical angles are a little easier though, right? Then you don't have to deal with the 180. Okay, how do we solve for y? Yeah,
Same thing if you did for.
so what's the same, what do you mean same thing?
You would have to.
Does it equal 130?
You would have
Equals,
to equal 50,
good.
and then
There you go, right?
you would add 10.
Yep, so 3y minus 10 equals 50.
You add,
Then we add 10,
and then you would
and then we divide by 3, and we get y equals 20.
20.
60 divided by 3.
3 times
So
2.
you add 10.
You add 10 because that's a minus 10, right? We do the inverse operation. Okay? Easy stuff? Just using your algebra, but now we're looking at shapes and angles and stuff. So it makes a little more sense. Now you could plug that back in and make sure it works. That's 3 times 20 is 60 minus 10. Does that equal 50? Yes.
Yes.
So you know you did it right. Okay? Now what do all of these have to add up to? All 4 of these.
180.
This is 180. What's the other side? So it's
360.
And you guys know that all the interior angles of a square or a rectangle have to add up to 360. It's interesting, right? Okay, here's another one for you. Example 2. We have 115 degrees, and then we have a 5x. Solve for x. What do you think we should do? Yeah?
Divide by 5.
Not quite. What do they have to equal? What do they equal? 180. Good.
Oh.
Solve for x. They have to equal 180. These are supplementary, right? Flat line, and they share this whole thing here is 180. So we have 115 plus 5x equals 180. And then what do we do? What do we do, Nick?
You want to subtract 115.
Good. We subtract the 115 because that's a positive 115. We need to make it 0. So we subtract it. Then we get 5x equals 65. And then that's where we divide. Okay? That's when we divide the 5. So you should get 13. And you could double check your work here too, right? You could plug in 13 right there and it has to add up to 180. So the first example we use vertical angles, right? The second example we're using supplementary. Do you think we should do another example of complementary?
Yeah.
Yeah, why not? You guys got this? Almost? Okay. Now what does complementary mean?
Equal to 90.
Equals to 90, adds up to 90, good. All right, turning the page.
Yeah.
Okay, so here's the 90. Example 3. So we have 60 and 3x, okay? And this is the 90 degree. Technically, it should have a box on it, so I'll put that in there. Just so you know it's 90, even though you can, like, pretty much tell by the picture, but we should be exact here, right? So let's put a little box to make sure everyone knows that's 90. So now these two have to add up to what?
180.
90, right? That's okay, we just did a 180. So now that's 60 plus 3x equals 90. Hold on one sec. I know, hold on. Let them get there.
You minus 60 or minus?
You minus the 60.
Oh, I got it.
Good. So now you have 3x equals 30, and then divide by 3, x equals 10. Is there a shortcut? Who sees the shortcut? Raise your hand. Who sees it? Anastasia, what shortcut do you see?
I just see it's obvious that 3 times 10 equals 30 and 30 plus 60 equals 90.
Okay. So you could find the difference. So you already know your shortcut. This has to equal 30, right? It has to. Because that's 60 plus 30 is 90. So if you already know that has to equal 30, then you could say, oh, that's 10. You guys see the shortcut? Okay. If you got decimals or fractions, though, it would be easier just to set up the equation, okay? Any questions? So we did vertical, complementary, and supplementary. We're going to do some practice in your book. The first practice we're going to do is on 539, 1 through 11.
Are we done with the notes?
Yes, you're done with the notes. 539, 1 through 11. We're going to look at that.